Hi everyone, this is a third example of chapter 7.1. It is question 134. Let's read the question. Question 134. Consider a single slit diffraction pattern for lambda is equal to 589 nanometer projected on a screen that is 1 meter from a slit of width 0.25 millimeter. How far from the center of the pattern are the center of the first and second dark fringe? First, let's write the relevant piece of information. We have our lambda, 589 nanometer. I decided to use x for the distance between the slit and the screen. It's equal to 1 meter. The width of the slit is 0.25 millimeter or 2.5 multiplied by 10 minus 4 meter. What we're looking for here is the distance on the screen between the central maximum and the first and second minimum. All right. Now, if we were to extend the central line over here with the screen, we will see that it forms an angle of 90 degrees. If it forms an angle of 90 degrees, that means we have a right triangle over here. We can find the height over here by using trigonometry since we have the adjacent side, and we can use our formula to find the minimum to get this angle. So because both pieces of information we're looking for require the exact same step, I'm going to write general formula. So the first step we need is we need to find the angle over here. We use that formula, we isolate the angle. I decided to write theta m. M stands for depending which minimum we're considering, and obviously the m over here inside the inverse sign and the m here has to match. So in this case, it will be 1 for the first part and 2 for the second part. After that, we write tangent. Tangent of the angle is equal to the height. Again, I wrote ym, y for the height, and m for depending on which minimum we're considering. And again, these two m has to match. Divided by the adjacent side. Now in this case, the adjacent side is exactly 1 meter. Well, that means it kind of cancel out. So we isolate ym is equal to the tangent of the angle over here that we measure. And if we plug in all the value we got, we'll find the first height, so the distance between the central maximum and the first minimum to be 0.0024 meter. And if we plug the value for the second minimum, and by the way, the only thing that changed when we are considering the second minimum is now that m is equal to 2. Everything else is the same. Lambda does not change, the width does not change. So only m is now equal to 2. And using our 2 formula, we get y2 is equal to 0.0047 meter. All right, so that's it for the example concerning chapter 7.1. In the next video, we're going to introduce chapter 7.2, the intensity of light being shone upon the screen. All right, see you there.